All right, students, welcome back. Let's get right into it. Next section, 10.4, inscribed angles. And we're looking at the note guide. So let's start off. What is an inscribed angle? Well, an inscribed angle is an angle whose vertex is on the circle and whose sides are chords. Remember, a chord is just a line segment that goes from one end of the circle to the other end of the circle, okay? So notice that QRS here, that's an inscribed angle, okay? Notice R is the vertex on the circle, RQ and RS are chords. Now, if you scroll down here, notice the difference between this and this picture, right? So on the left, you have an inscribed angle, right? XV and XW are chords, and X is on the circle. But notice that in this picture on the right, that K is not touching the circle, okay? K is kind of like hanging in the circle. So that would make it not inscribed. It's not a central angle. It's just an angle inside of a circle, but it doesn't have a specific name, okay? All right, so then an intercepted arc. Well, an intercepted arc is the arc formed by an inscribed angle. So in figure 1, right, QS is the intercepted arc of angle R, right? So it's kind of like, angle R would be, maybe Jameis Winston, right? And maybe arc QS would be Marlon Humphrey, right? So Marlon Humphrey is going to intercept Jameis Winston, right? So the R would be the angle, the quarterback, and the arc that it makes would be the cornerback, right? Intercepting the angle. Okay, so this leads to the following theorem, which is called the inscribed angle theorem. Okay, now what does this say? So this says that the measure of an inscribed angle is half the measure of its intercepted arc. So in the example figure 2, the measure of angle 1 is equal to 1/2 the measure of arc AB, or the measure of arc AB is equal to, well, if we multiply the first equation by 2, we get 2 times the measure of angle 1. So the arc is always bigger than the inscribed angle. The angle is half of the arc, or you could say the arc is double the angle. So in example 1 here, notice since arc LK is 62, angle N is 31. In the next one, angle Z is 23, so arc XY has to be 46 in measure. Now, in this last example, notice that we have 120, 140. We need to find the measure of angle R here. We'll call it X. So 120 is the measure of this blue arc here. 140 is going to be the measure of this red arc. So that's 260, but remember, the entire circle is 360. So that would leave 100 degrees for the measure of QS. And remember, the inscribed angle measures half of the arc measure, so that's going to be 50. Okay? All right, let's try some harder examples now. In example 2, we want to find each measure. Well, again, measure of angle C, so we're trying to find this angle. So again, remember, inscribed angle measures half of its intercepted arc. Well, angle C intercepts arc DE. So DE is 98. So the measure of angle C has to be 49. Now, if we want to find the measure of arc CF, again, arc CF corresponds to angle D. So that's the angle in green. So 2 times 40 would be 80. That's how we get CF. Okay, so remember the arc is always double the inscribed angle measure. Remember that central angles and their arcs had equal measures, but inscribed angle measures half of the arc measure. Now notice in example 3 here, if we want to find the measure of arc CM. So notice there's no inscribed angle there, right? And we need x first. So we need to find x before we figure out the measure of arc CN. There's an x here, though. So this angle is probably going to have to play into this. Well, that's angle L. And if you notice, hey, angle L intercepts arc CNM. So we could say that 2 times 11x plus 9, right, is equal to 11x plus 84, which is the entire arc CNM, right? Because 2 times the angle measure is the arc measure. So we get 22x plus 18 equals 11x plus 84. We get 11x equals 66. X equals 6. And the measure of arc CM is 70. So again, not every problem is going to be so easy as, oh, this one is double that. You may have to sit and think a little bit, but the goal here is to figure out, right? Find an angle, right? And then find out which arc that angle intercepts, or find the arc that intercepts the angle. You know, so again, like in this problem, we need to find ST. Well, ST is this, right? You know, and again, well, angle R is going to be half of ST, but we don't know what angle R is. So you may have to think, what about all the way around, right? What if I did half? This is half a circle. That's a semicircle, right? See if you can figure out arc ST from that. And again, in this problem, right, we're trying to find the measure of arc TEF. There's no angle that intercepts that, and it's not a semicircle. So again, we're going to have to think about how can I use the inscribed angle theorem to eventually help me get what I need. Well, hey, if you look, this green arc here, right? If we can figure out what that is, then we can do 360 minus that equals the red arc, right? And we're probably going to need to find x. So again, it all comes down to the inscribed angle measure is half the measure of its intercepted arc. And then you just have to figure out which arc matches up with which angle. Play around with it. Remember, semicircles, measures are 180, okay, etc. All right, I'm going to skip that part. Okay, so we've got 2 more theorems left. So what happens if we draw triangles and quadrilaterals inside of circles? Well, and specifically we're talking about inscribed. So inscribed polygons have all vertices on or touching the circle. So, for example, that is not an inscribed triangle, okay? That triangle doesn't touch the edge of the circle. In this picture, triangle FGH does. F, G, and H all touch the circle, okay? So it's inscribed, all right? So that leads to our theorem, inscribed right triangle theorem, which says if a triangle is inscribed in a circle with one side as the diameter, the side, or then it is a right triangle. So notice in this picture, right, one of the sides of the triangle here, FH, is a diameter. And remember, that means that this is a semicircle, okay? Which means that this red angle intercepts that arc. But any angle that intercepts a semicircle has to be half of it. So if this is 180, half of 180 is 90. And if that's 90, then this is a right triangle. Okay? So, if we look at this problem number 8, find x. Well, look, we've got one side is the diameter. So that means that this arc is 180, and angle M is half of 180, which is 90. So it's a right triangle. And then we notice, hey, well, look, we've got some slashes here. So that means this is isosceles. So both of these angles have to be 45. And then we'll say, hey, well, 2x minus 5 is equal to 45. 2x equals 50. And x equals 25. Okay? Now over here on the right side, we want to find the measure of angle CAB. Well, notice this one's different, right? This side right here, AB, is not a diameter. So we can't use the formula that I just mentioned. Okay, that's just to show you that one of the sides, right, of the triangle has to be a diameter. Okay? If so, it's a right triangle. Now, in this case, we would just use the theorem that we started with, the inscribed angle theorem. So notice angle A is intercepted by arc BC. So 2 times 5x plus 5 is equal to 11x plus 3. So we have 10x plus 10 equals 11x plus 3. X equals 7. The measure of angle CAB is 40. Okay? So that's just to show you that you only get a right triangle when one of the sides is a diameter. Okay? Basically, the angle opposite that side is going to be 90 degrees for the reasons mentioned earlier. Okay, last theorem is inscribed quadrilateral theorem, which says opposite angles in an inscribed quadrilateral are supplementary. Which means they add to 180 degrees. Okay? So, in this example, in this picture right here, measure of angle M plus the measure of angle K would equal 180. Measure of angle L plus the measure of angle M would be 180. And so if I'm looking at example 10, I want to find the measure of angle T. Well, notice this is an inscribed quadrilateral. There's 4 sides, and each vertex is touching the circle. So W and T would be supplementary. So that means that T would have to be 135, because 180 minus 45 is 135. And if we wanted to find the measure of angle Z, well, Z and R are opposite angles. So we could say 6x plus 30 equals 180. 6x equals 150. X equals 25. And the measure of the angle Z is 80. Right, because 2 times 25 plus 30 is equal to 80. So again, the three big takeaways here: opposite angles in an inscribed quadrilateral are supplementary. A triangle that's inscribed in a circle with one side as the diameter is a right triangle. And the measure of an arc is double the measure of the inscribed angle, or the measure of the inscribed angle is half of the arc measure, okay? So I'll go ahead and post these for you, okay? And maybe we'll finish up, try number 11, example 11, okay? And yeah, I'll talk to you guys on Monday, all right? Have one.